gonna talk about the sine and the cosine function, sine of t and the cosine of t. Actually, let's say the negative t here. What happens when you take in the sine of a negative angle? Can you just take the sine of the positive angle? That is, does this equal to the sine of the positive angle? The answer is no. That negative sign, that plus minus negative sign, it factors out the sine of t with a negative in front. The cosine of negative t, it doesn't care. Positive 7, negative 7 degrees, negative 50 degrees, positive 50 degrees. The cosine of those two angles are equal. Cosine of negative 50 degrees is equal to the cosine of 50 degrees. The sine of negative t, on the other hand, it equals negative sine of t. Okay. What this is telling us is that the sine function is odd function because the negative from the negative argument comes out in front. The cosine, not caring whether you plug in a negative angle or a positive angle, is called an even function. And we are going to prove those two statements up there and a few more. So our strategy is we're going to put angle T in each and every quadrant. If I put T in the first quadrant, that is, if that's angle T, we get this triangle. And negative T just means we go in the opposite direction the same amount. So if this is A and B and C, well, that's in the top triangle. In the lower triangle, that's still going to be B and C, but this is going down now. This was going up, this is going down. They're going to differ by signs. Now, in quadrant 1, we're going to look at the sine of t and the sine of negative t. And the sine of t is opposite of t divided by the hypotenuse, which is opposite the right angle. And the sine of negative t, let's label that negative t, is going to equal the opposite, negative a, divided by the hypotenuse is c, which is c. And what we notice is that they're not equal. A over c and negative a over c, they differ by a sign. That is, the sine of t and the sine of negative t, they're not equal. That minus sign comes out in front. I can put the minus sign on either side of that equal sign. Think about why. Okay, so we prove that in quadrant 1 that this identity up here is true for sine. Well, what about for cosine? The cosine of t and the cosine of negative t. Well, the cosine talks about the adjacent with respect to angle t, the top triangle. The adjacent is b and the hypotenuse is c. So we get b over c. In the bottom triangle, where the angle is negative t, the adjacent to t is still b. They both share, both of those triangles share the same adjacent. So we get b over c. Oh, look at that. They're equal. That means in quadrant 1, the cosine of t, the cosine of negative t, they're equal. Well, that's exactly what this says. Okay, so for quadrant 1, what I wrote on top is correct. Doesn't mean it's going to be correct In the other quadrants, we need to verify that. So we go into quadrant 2 and we go t degrees and we get our triangle A, B, and C. And like I said, t degrees. Now, the sine of t degrees comes from this triangle. And the sine is opposite over hypotenuse. It is B over C. Negative t goes the same amount, starts in the same place. It goes in the opposite direction. This is going to be A, and this is going to be the same length as up there, but it's going to be negative that length. And, oops, and the sine of negative t is going to be negative B over C. Once again, they differ by our negative sign. That is, sine of t and sine of negative t, well, they're not equal unless, oops, I meant to put the bracket there. They're not equal unless you put a negative sign. Now, if you put the negative sign there, that would be equality, but then you can multiply both sides by negative 1. When you multiply this by negative 1, you'll get negative sine of t. And when you multiply this by negative 1, you'll get positive sine of negative t. And you don't need that positive sign. Oh, that's exactly equation 1. Now, let's verify equation number 2 in quadrant 2. The cosine of t, the cosine of negative t. The division, the cosine of t. That means I'm in the top triangle. Why the top one? Only because that's where t ended. Cosine of t, cosine of this reference angle. It's the adjacent divided by the hypotenuse. A over C. Now, let's look at the triangle associated with negative t, which is this triangle. The adjacent, this adjacent is still A. The hypotenuse is C. So, in quadrant 2, since A over C equals A over C, we have that the cosine of t is equal to the cosine of negative t, which is exactly statement number 2 on the top. Can't get that negative sign in there. Try it again. Cosine of negative t. So, it's true, the two statements on top are both true in quadrant 1 and now in quadrant 2. So, what do we do next? Go on to quadrant 3. Angle T ends right here. And it generates that right triangle. Negative T goes the same amount, just in the opposite direction. It ends right there. Negative T. Now for T, for this triangle, I'll call this A, I'll call that B, and the hypotenuse C. Well, let's put the A down there. For the top triangle, The a's are the same. Now this is going to be negative b because this is going down. Everyone will say, well, you should call the bottom one negative b. Nah, I mean, if b is negative 3, for example, well, then negative b will be negative 3 or 3. So I do have it going up being positive and going down being negative. They just have to differ by a sign. The value of my b has to be negative. Okay, now what is the sign of t? What is the sign of negative t? How do they compare? What's the cosine of t? The cosine of negative t. How about we do cosine first? Cosine of t, which means I use the bottom blue triangle. Why? Very, very simple reason. Very simple reason. Because angle T ended up right there. It's in their lower triangle. And the cosine is, for this angle, is the adjacent divided by the hypotenuse. It is A over C. The cosine of negative T, well, negative T ended up in quadrant 2 in the red triangle. And the cosine of this reference angle is adjacent, which is A, divided by the hypotenuse, which is C. So once again, in quadrant 3, we see that cosine doesn't care whether the angle is negative or not. And what about the sine of t? Sine talks about the opposite. Well, like we said a moment ago, angle t is associated with this reference triangle, where that's the reference angle. And the sine is opposite divided by hypotenuse. It is b over c. And the sine of negative t, well, negative t is associated with the right triangle in red. And this here is the reference angle. The sine is opposite, which is negative b, divided by the hypotenuse, which is c. Sorry that it looks so messy. These differ by a sign. That means the sine of t, it doesn't equal to the sine of negative t. It equals to negative sine of t. That's the proof for quadrant number 3. Now, let's go into quadrant number 4. Bottom right quadrant. That's going to be angle T. Let me label that elsewhere. That's going to be angle T. And it generates that triangle. Now, negative T is just going to go the opposite direction, the same amount. And we end up right there. It's the same game. The adjacents in both triangles are going to be the same. The hypotenuses are always the same. That tells us that the cosine of t is going to equal to the cosine of negative t. However, if I call this b, then that's going to be negative b. The opposites differ by a sign. Plus minus sign. So these two will not be equal. They'll differ by a sign. And there's the proof that sine function is odd and the cosine function is even. Now, while I was doing this in all 4 quadrants, I could have talked about the tangent of t and the tangent of negative t. For example, in this example, the tangent of t is opposite over adjacent. It would be b over, it will be b over a. And the tangent of the blue triangle, it'd be opposite over adjacent. It would be negative b over a. And since these differ by a sign, so will the left side. That is the tangent of t and the tangent of negative t. They're not equal, but negative one side is equal to the other side. But again, we didn't do that. I did it for this triangle, but there's a quicker way of doing it in my opinion. We're supposed to know that the tangent of negative t is equal to the sine of that angle, which is negative t, divided by the cosine of the angle. Well, for the denominator, we get cosine of t. And for the numerator, we're going to get not the sine of t, but negative the sine of t. And what happens is, that's tangent of t. Not my fault somebody went and put a negative sign in front of it. That is, the tangent of negative t is negative the tangent of t. That is, tangent function is an odd function. Tangent function is odd. Well, what about, say, the secant of negative x? Well, secant of any angle is cosine of that same angle. But the cosine of negative x is just the cosine of x. And 1 over cosine of x is secant of x. That is, the secant function is even. The reciprocal of an even function should be even. Number 5. The cosecant of negative x. Well, by definition, that's 1 over the sine of negative x, which is 1 over negative the sine of x, which is negative 1 over sine x. There's a negative, and 1 over sine x is cosecant x. Ooh, that's an odd function. And the last one, the cotangent of negative x. Well, that's the reciprocal of the tangent of negative x, but the tangent function is an odd function. That is, the tangent of negative x is negative the tangent of x. And that's the same as negative 1 over tangent x, but 1 over tangent x is cotangent x. That is, just like the tan function, the cotangent is a reciprocal of trig functions maintain their parity. If one trig function is odd, then its reciprocal will be odd. If a trig function is even, its reciprocal will still be even. The reciprocals maintain the same parity. And we have all 6, so that completes this video.